Hello again, this is Mark Summers from Summers Technical Services. This is our second video for our Assignment 5 GD&T assignment we're working on this week. So you should have already read the lecture slides and watched the first video when I talked about the datum reference plane and locating the part, defining the part data reference frame to get rid of all the 6 degrees of freedom using one scheme. And we're going to use a different scheme in this video that you're going to use when you do your assignment 5 drawing. So let's go to SolidWorks and take a look at the part. So if you've already downloaded a part from Blackboard for assignment 5, delete that. I just placed a new one on Blackboard. It's a step file. A step file is a neutral file format that allows any CAD tool, any 3D CAD tool can open up a step file. It's a neutral file format, which means it's not an Inventor file, it's not a SolidWorks file, it's not a Unigraphics file. It's a universal file that can be read by any CAD program. So let me show you how to do that. We're going to start with a step file and turn it into a dumb, what I call a dumb SolidWorks part. So the first thing you do is go File, Open, and you're going to move that file that the new step file you've downloaded from Blackboard into your assignment 5 folder on your hard drive. Like you've been doing, you should have assignment 1, 2, 3, 4, 5. Every assignment needs its own folder, like we talked about that first day of class. So you're going to go into that assignment folder, and you're not going to see that step file because SolidWorks by default looks for only SolidWorks part models, assembly models, and drawings. So it won't be on the list. So you have to pull down this filter down here, pull this down, and say you want to look for step files. There's lots of other file formats that'll open. We're going to deal with step files. And when you do that, it'll only list the step file. So you'll open this up, and it will convert it into a SolidWorks part. So the first thing we need to tell is which template to use. And since it's an inch part, we'll use the inch part template. And as it's reading it, it's going to ask us, it's going to do some error checks. And it's going to find, if it finds any errors, it's going to ask us if we want to fix those errors. And if it doesn't find any errors, it'll come to this pop-up. It says, do you want to run import diagnostics? Yes, I do. I want it to check to see if the part has got any errors. So I'm going to say yes. And it goes through and does a check, and it finds an error on one of these faces. So I'm just going to select that face and say attempt to heal all. And hopefully SolidWorks can fix whatever's the problem, and I got all green lights. So it looks like it did that fine, so I'll say OK. Now it's asking to do feature recognition. Well, I don't want to do feature recognition. I could, and it would go through and start trying to create real features. But I just want this dumb model. This part's already been designed by me. All I want to do is make a drawing of it, and so there's no need to do feature recognition. So here I'm going to say no. And so when I say it's a dumb model, it's because exactly that. Here's one feature. It just says imported solid part. And so there are no holes and faces and sketches and such. But this is fine. Then you'll just do a file save as, and you'll save it as a SolidWorks part. So you'll change the filter to SolidWorks part, and you're going to want to call it, if you're student 99, you'll call it campus, class number, student number, and this is assignment 5, like such, and you'll save that, and then you'll have that part, and that's the part you'll use to make your drawing views. So we'll just save that for fun, close this out, and we'll go back to the drawing. It's the same drawing showed you on the first video. Oops, let's go back to the drawing, which is right here. So again, you'll make top view, side view, and a section view of that step file that you converted to SolidWorks part. Make sure not to do a views of the step model. You want to do views of the SolidWorks part, like I showed you just how to make. And then we'll be adding the datums and the dimensions and the hole callouts and such to finish the drawing. So I'm going to go over to this assembly model, and I don't have these parts fabricated yet. But I'll use this virtual assembly here to show you what we're talking about. So this is going to be a go, no-go fixture. that's going to allow us to test these parts to make sure that they meet the requirements of the drawing. And so here's my 321 block. These are gauge pins. These are precision gauge pins that are the diameter plus or minus probably a few tenths of a thousandths of an inch. And we're going to define those, we're going to make those diameters the maximum material condition of the counterbore holes in the part. And you'll need to again go through those lecture notes to learn about maximum material condition, what that means. Okay, so I'm going to have this plate. I'm going to highly precision fabricate this plate so that the size of this block, the size of this cutout, is as close to 2 inches by 3 inches as I can get, because I want to use this green part as a datum simulator. I'm going to use this gauge block as a datum simulator, and I'm going to use these 2 pins as datum simulators. So these are highly machined, high tolerance parts that are going to represent the datums, and that's why I call them datum simulators. So let's put this thing together. So I want to place this gauge block on this pocket that I've precision machined on this piece of whatever this material is. So I'm going to mate these 2 parts together, and we'll learn more about this assembly model when we get to assignment 6, but for now I'll just do a quick assembly. So I'm going to mate those 2 planes together and wait patiently by when SolidWorks wakes up. Alright, so I'll prove that. Now that thing is sitting at the bottom of that pocket. Now I need to move it. This thing has got a big delay here. I'm going to move that go no-go block to sit inside this pocket. So I'm going to mate that face with this face. Right here. Mate those together. So I'm basically tying down the degrees of freedom of this gauge block so that it is fixed in space based on this plate I'm machining here. And then the last face is going to be this face. Oops, I need a face, not an edge. That face mates to this face. Mate. And like I said, we'll be learning how to do these assembly models in on assignment 6. So you have to take my word for it here. What am I doing here? Why didn't it like that? Oh, I didn't grab this face. I want that face to line up with that face. That looks better. Okay, so now the 321 block is sitting nice and snug in that pocket. So now that gauge block has all of its degrees of freedom tied down. Now I want to place these pins inside these precision drilled holes in my plate. And I'll do the same for both of them. And I'll lock rotations for reasons we'll talk about when we do assignment 6. And I'll do the same on this one. This one needs to mate to this hole. So I'm putting my precision gauge pins in my precision drilled holes for my on my green plate. That'll create my go no-go fixture to check my parts with. Do another lock rotation. All right, and I need to put these pins in here so that they are flush with the bottom. So I'll drag this one down. Drag this one down. Then flip this thing over. It's taking longer than I'd hoped. So that face I'll make flush with the bottom. And do the same thing on the second one. There we go. And do a similar thing over here by grabbing the bottom of the pin, bottom face of the pin, bottom face of the plate, mate. Okay, okay. And you'll see the negative signs on these parts, they start disappearing when I completely constrain the parts and there's no more degrees of freedom left. So this is what you want to do on all your assembly parts. All right, so now I've got my go, no-go fixture assembled. And now what I'm going to do is create my datum reference plane for the part. And so this scheme is what you're going to use for assignment 5, as opposed to the scheme we used on the first assignment, or the first video, excuse me. So what you're going to want to do is determine what is your primary datum. And the primary datum is the bottom of this part. I want that to define the primary datum because that's the way this part is installed. That's the design intent, is this part's going to be installed on a plate, and that's the first plate it mounts to. So I'm going to select this face, control click this face, and mate those together. So once I mate that, once I plop that part on my go, no-go gauge, 3 degrees of freedom of this part are taken away. So now it can still move left and right, just like it could on the first video you just got through watching. Get another ISO view here. So this thing can still move left and right, can move front to back. It can also spin about the Z-axis. So those are the 3 degrees of freedom left. Now what I want to do is I want to define datum B as a center line of this hole over here. So instead of having a face define a datum, I want an axis of this pin to define a datum. So datum B is going to be the axis of this through hole in this part. And so what I'm going to do is select this pin. I'm going to control click that through hole, and I'm going to mate that pin, mate the hole to the pin to get rid of some more degrees of freedom. So now what have I got? Well, I've got my part, and with the first datum, datum A, I've got rid of 3 degrees of freedom, so there's 3 degrees of freedom left. I've got rid of 2 more degrees of freedom by using this gauge pin to locate this hole, and the only thing I can do now is rotate about the Z-axis. And so to tie that down, I'm going to use this face to be parallel to this face and make that last degree of freedom go away. So I'm going to select that face, I'm going to control click that face, and I'm not going to make them coincident, I want to make them parallel to one another, and you can watch and see what happens to that part when I say OK. So now that part is giving me an error. Why is it giving me an error? I'm going to edit that mate I just made, and I think I forgot to turn it into a parallel mate. Let's see if that was the problem. Right click, edit that mate. And I should get a pop-up somewhere. There it is. So I don't want coincident, I want parallel. I didn't choose the right mate. So that's going to be parallel. I can't make it coincident because it's got an offset there. So I want to make it parallel and watch it, see it rotate into place. So now this last datum is going to be defined by the distance between this face and the face of the part. So what I would do is I would get gauge blocks and put them in between this gauge block and this face of the part. Remember, this is the datum. This is, in this case, is going to be datum C this time. That's the last datum. And I would put those gauge blocks in there until it fills up that gap. So now what does this tell me? Well, if this part will fit on these pins, and I know it's made to the requirements based on bonus tolerances that we'll talk about in the next video. But what you need to take away from this exercise here is what are the datums on this part. The datums are, datum A is at the bottom of the part. Datum B is defined by the center of that hole. That gets rid of 2 more degrees of freedom. And then the third datum is going to be datum C, which is going to be the face that was datum B before. You'll use that and you'll define those datums on the drawing. And then when you locate those holes, all of the dimensions that locate those holes are going to come from those datums, and they're going to be basic dimensions. And once we locate those holes using those basic dimensions, then we're going to add a feature control frame to define the positional tolerance of those holes. So that's what we'll do in the other video. So now that you've got that understanding, you can go up to your drawing. I choose the right drawing. You're going to define those datums. We got different datums here than we had on that first video. You'll define those datums just like I defined them in that assembly model. And then you'll add those dimensions to the holes located from those datums. And then we'll put feature control frames. So the next video we'll talk about how to add those feature control frames. So that's it for now. Let's minimize that and minimize that and come back over here. There we go. So that takes care of the second video. We've got one more video that'll show you how to do those feature control frames. But based on what you've got, you can start the assignment 5 right now. Make sure to convert the step file into a part model, and make sure to download a new copy of that step file because the one that was on there last week is old. So don't use the old one. Go download a fresh copy after you watch these 2 videos. So we'll talk to you in the next video.